I guess a good time to give you a message. You realize that if you're studying with a teacher that gave you a problem set like this, or was at the board doing problems like this, it'd probably be in your interest to listen to what they're doing because they probably think that's interesting. And if they think that's interesting, it's probably going to pop up on the exams. And that's true with all your subject matter. It's what the teacher's talking about. That's what they're going to examine you on. Now, granted, that's not always true. For example, at a big university, the teacher may be giving you an exam that they'd never even looked at. All right, that's a possibility as well. So that's often a shock, by the way. But I think for the most part, regardless of where you are, most exams reflect what the teacher is interested in, all right, with few exceptions. So I'm kind of looking at this problem over here. And what I want to do is I want to talk about like just looking at the key. Now, before I do that, though, I want to point out the second equation, relatively simple. If you wanted to, you could solve for y or x and plug into the first one. But I'm pretty sure that this guy here is going to factor, all right? So I want to go through that with you and talk about it in stages for you. So this is the first equation. And someone says, why do you want to factor that? Because it's going to make my life a lot easier if I can factor it. And then I can use the zero product rule. So what I did first was I grouped the first two terms and the last two terms. Again, there's two terms, two terms. I grouped it, just like you would do in any basic level factoring course. So looking at the first two terms, an x squared is common between those two first terms. And what are you left off with? Well, you'd be left off with 2x plus 5y. And why is that? X squared times 2x is 2x cubed. X squared times 5y is 5x squared y. And then I look at those last two terms, and I notice they've got a 4 in common and a y squared in common. I like to factor out the minus sign now. And what would you be left off with? 2x plus 5y. Does that work? You do get minus 8 xy squared minus 20 y cubed. Worked beautifully. What do I notice now? There's two terms now with a common factor. Let me write that down for you. 2x plus 5y. What's left over? X squared minus 4y squared, and that equals 0. Continue to factor. This would be x plus 2y, x minus 2y equals 0. So what do? I'm using a zero product rule. So for example, this factor becomes 0 when x equals 2y. This factor becomes 0 when x equals minus 2y. Now the other one's a little bit more difficult, but what is it going to be? And I'll write it down for you. 2x plus 5y is equal to 0. 2x equals minus 5y. Divide by 2, what do you get? X equals minus 5/2 of a y. Let me show you where that's written down. Right over here. Then what do? You take these that we've been doing for a very long time and plug it into the second equation, which is 3x plus 4y. You just plug it in. So I'm plugging in, this one goes here, you solve it, you get y. I'm hoping that's relatively simple to do. Well, if y is 7/10, you multiply it by 2 to get the x, and that would be 7/5. Relatively simple. Then what do? You take the next guy, x equals minus 2y, you plug it in, you solve it, and I think it's pretty easy to come up with the y in this one as well. How do you get the x? Multiply it by minus 2, and you get 7. What's the third equation? The third solution problem, x equals minus 5/2 of y, right there over there. Plug it in, relatively simple. You'll get y equals minus 2. And how do you get the x? Plug it in. Y is minus 2. So what do you get? You're going to get plus 5. Relatively simple. Now granted, graphing can be difficult. I would say look at the graph. If you can't get the graph yourself, that's fine. But the graph, did I put a graph down somewhere? Yeah, I think I did. And let's just take one easy point. All right? I'm going to say the easiest point over here is 5, comma, minus 2. Right there. Let's take another point. And I'm going to say 7 minus 7/2. That's 7. Minus 7/2 is minus 3.5 down. What's the other point? Not easy, but it's a point. It's going to be 7/5, 7/10. Right there. All 3 points of intersection. By the way, put all lines down. We've been talking about graphs for a long time. Why are they lines? Let's go through that. I'm not going to label them this time, but you're going to get basically a bunch of lines. What lines you're going to get? you're going to get 2x plus 5y is equal to 0. That's a line. You're going to get x plus 2y is equal to 0. That's a line. You're going to get x minus 2y is equal to 0. That's a line. And the other line you're going to get is 3x plus 4y equals 7. And what does that going to be? Line. How many lines are you going to get? 4 lines. Look at the graph. You should clearly, let me count them up. 1, 2. Boy, they're tough to count, aren't they? There's 4 lines there. All right, there's 4 lines. All right, let me remind you who I am. I'm Ron Bannon. If you have a question or concern, reach out to me. My email address is Bannon. That's B as in boy, the @ symbol, NNON.US. And again, I'm pretty much responsible for writing the document. I've had no help with that. The question about this, though, could I have made an error? Of course I made errors. Of course I misspoke. Of course I did something wrong. That's a given. What do? You see something, you say something. Why would you do that? To improve the document for other people. This is a really high-quality algebra text that would benefit anyone by reading it, including teachers and other mathematicians reading it. They would benefit by this. I think one thing you start to realize about algebra, the way it's taught nowadays, it's really a horribly dumbed-down subject. All right? Look at this. It's a great document dating back to 1904. It's well over 100 years old. The question is it still valid today? Of course it is. It's a remarkable text. Thank you.